Hi guys, Buildzoid here, and so I've got a stack of not working GPUs in front of me, as you can clearly see. All of these cards are like kind of old AMD GPUs, but I got them for like 10 quid each, including shipping, which I consider an acceptable price for these cards, because on eBay basically there's a lower limit to how cheap a card can be, even if it's broken, and it's somewhere between like 5 and 15 quid, so yeah, I figured this was a pretty good deal. And today what we're going to do is we're just going to do basic troubleshooting that you can do without having to plug the cards in, because the thing is, there's a lot of defects with GPUs that you can, like, well, you should check every single card for certain things before you even plug it in. Once you know for a fact that there's no obvious, like, short circuits or anything like that, that's when you can plug it in and see if you actually have all of your different voltage rails. And if you do have all of your voltage rails, that's when you decide that you've got silicon damage and you throw it in the oven, which I still don't recommend, but, you know, past a certain point, it's like there's not really that much you can do. Anyway, or in my case, I use the toaster. So let's get to it. This first card is an HD7950, and I did actually already troubleshoot this because this turned up, and I was super excited because it's a red PCB. I'm a sucker for these red PCB cards. I still need to get a 290X with a red PCB. Like a Hawaii Hawaii red PCB card. It's probably gonna end up being a Fire Pro or something, but yeah. Anyway, let's get to it. So the first things first, is there a short circuit on our memory power rail, which is this rail down here on this PCB? And that's a little low. Yeah, 9 ohms is like suspiciously low for memory power. So that's a bit weird. Yeah, that is kind of weird. Wait, is it shorting out against... Oh, it might be shorting out over all the... Because this is metal. This is plastic, so that's fine, but then we have all these metal, so we'll just throw some bubble wrap on here. And take that again, because, yeah, I didn't really think this through. Nah, it's actually 9 ohms. Okay, that's suspiciously low for memory power, but should be okay. Like, yeah, that's not what I want to see. 2 ohms for V-core, that's fine. That's a healthy core. We got 20 ohms on the... Wait, do I have it backwards? Is this... No, this is not the memory. That's memory power. This is memory controller power. But anyway, memory controller is 20 ohms. So that's one healthy memory controller. So that's all good, mostly. The memory is a bit suspicious, so what we should do now is check the memory resistance to our 12 volts power. So there's 3 12-volt sources on any GPU. You've got this GPU has 3 12-volt sources. You've got your 2 6-pins, and then you've got your PCIe slot over here. You can try probe off of the pins, and actually with this red PCB, it's really clear which pins are connected to the 12-volt power plane over here, so we could just probe off of that. But there's also this little capacitor here for input filtering. You could measure off of this side of that capacitor. And then there's like a bunch of points up in this area, which will also be 12 volts, but I'm not sure which one. So I'll take the capacitor because it's a bit easier to stab into solder than into gold pins. And let's see if that's shorted to... Okay, well, actually, we should check 12 volts to ground. 12 volts to ground is fine. 12 volts to memory power is also fine. 3 kilo ohms is what you'd... somewhere in the line of what you'd expect. Like, if it's in the kilo ohms range, it's probably fine. So that's that. Let's check to memory controller. Memory controller also fine, and V-core, which is kind of awkward, so I'm going to stab the back of the inductor. That's also in the 3 kilo ohms range, so we can assume that this is not shorted to anything. Now for the 6 pins, we've got these 2 input filtering inductors, and I don't actually remember how the 6-pin power connectors are wired up. It's just not something I care about, because normally you have input filtering input filtering passives that you can use, like these capacitors over here, but I do prefer the inductors. So I'm going to go off of the inductor over here, and we're going to measure that inductor to V-core. And yeah, that is shorted. That is very, very shorted. That is 0.03 ohms. That is a short circuit. So, and the other inductor, right? So that's this one. And inductors are basically a fancy piece of wire, so you can actually measure the resistance on them from either side. And this one's not shorted, but this one very clearly shorted out. So that's going to be, I'm assuming that one's connected to like these 3 MOSFETs down here. And I also want to check the memory power. Yeah, okay, so I wonder if it's like shorting through vCore or something. Yeah, it's probably... So there seems to be a short circuit in the memory phase, like in the memory VRM, and there's a really big short circuit in vCore. So I would do vCore first, and then this might clear itself up. Because the thing is, a lot of this stuff is effectively parallel through the ground plane. So if the ground plane, or, well, the resistance from core to ground is 2 ohms, right? So anything else connected to ground is going to have a relatively low resistance to 12 volts through the vCore power plane at this point. So, yeah, I think if we clear up the short circuit in the vCore part somewhere on vCore, then it's going to be fine. Now I just want to check which MOSFETs are actually shot. So we know we have a 12 volts to vCore short circuit. We should also check if we have 12 volts to ground, which you can't see it, but we don't, because I'm measuring 12 volts to ground. Well, that's the core resistance, right? Because the core itself is 2 ohms. So if there's a short circuit from 12 volts to the vCore, then you're going to measure 12 volts to ground, and you're going to get 2 ohms. So we don't have a 12 volts to ground short. We just have a 12 volts to vCore, and everything looks shorted because of that. In terms of which MOSFETs, so I'm going to just stab the pins of these MOSFETs. Okay, that's fine. Like, that's not shorted. I'm just checking which MOSFETs are connected to that power connector. Okay, so that one's also, and then this one up here shouldn't be. Yeah, so this red PCB is really super convenient because you can actually see where each MOSFET is connected to. And I think memory power shouldn't even be connected to this, but we'll see. Yeah, no, I think memory power comes from the PCIe slot. Yeah, memory power is from the PCIe slot, so this almost certainly doesn't actually have a short circuit. It's just looking weird because of the short circuit on vCore, which obviously also affects like the ground plane and everything. So we've got these 3 MOSFETs which are suspicious. I'm just going to grab a Sharpie and mark them as suspicious, and then I'm going to figure, and then we're probably, like, the way you would figure out which of the MOSFETs is shorted is you would basically feed current into the board, from, you know, to the vCore power plane and the 12 volt power plane, and you would just feed a little bit of voltage in, and whichever MOSFET starts getting really hot, that's probably the MOSFETs that is shorted. Now, considering that this has, like, this is a really, really shorted, like, this is really, really shorted out, where it's, like, 0.03 ohms, you're gonna need, like, either you have, like, a lab power supply with current limiting, which I don't. So what I'm going to do is I'm going to take like a 100+ amp VRM and hopefully not put a crater in the PCB. Anyway, so suspicious, suspicious, suspicious. Now, as for why this VRM failed, well, this PCB design is, like, this PCB is used on a bunch of cards with no VRM heatsink whatsoever, so that pretty much explains why the VRM exploded. Or more like why the VRM is shorted out, because it probably just overheated and then the MOSFET died. Though, it looks like whoever ran this card has a pretty fast power supply, because a lot of the time when you have a high-side MOSFET die, it causes a lot more damage than, like, this looks like a very healthy card, right? There's no obvious damage anywhere, so yeah, this should be very easy. It should, like, if I just remove the broken MOSFET, the card might even start working, and then it's just a matter of finding a replacement. So that's the first victim, or that's the first patient taken care of. Let's move on to this card, because let's get it up here. So we have a reference 7. Well, this is a 7970 twin Frozer. This uses a reference 7970 PCB, so nice VRM on this. I believe, actually, MSI has the full-fledged version of this VRM. So normally, reference 7970 will have a 5-phase flavor of this VRM, but this is on the actual full 6-phase. So that's pretty nice. I believe it goes vCore up top. We have memory, and then over here we have memory controller. We don't really have any capacitors available easily on the back. It's kind of sad, but anyway. I guess we could also take the card apart. Let's take the card apart. I think it'll make more sense to people if you see which stuff I'm probing from the front. Now this thing has a base plate, so kind of annoying to disassemble. Yeah, and this is truly the best way to do this, on top of a stack of other GPUs. Hopefully I don't need to take off the base plate. That's kind of what I'm hoping. Now, the thing with all of these cards is, like, I don't actually care too much about being able to repair all of them, because I did, like, at 10 quid a card, I kind of consider them good options for just spare parts. Oh man, so this thing has a really not, like, the base plate covers basically everything. So that's kind of annoying, because, yeah, we really can't stab as many things as I wanted to stab. Not easily, anyway. Oh, and then we have through-hole input filtering inductors, so yeah, you're getting you only get at those from the back. So, not the best PCB for this, in terms of accessibility. But yeah. And actually, the thing is, I just don't remember which part is memory power. This is R17, yeah, so this is memory power because these are all R15, by which I mean the inscription on the inductors. So you can see like R15, 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 R17. This one's memory power, everything else is vCore. And the reason why we need to know that is so that I know what I'm measuring. And then over here we have the memory controller juice. I'm also one-handedly reassembling the heatsink for this card so that I don't lose the screws. Come on, get in there. So actually, I'm just gonna see if I can get this. Okay, that'll work. The rear PCIe bracket is grounded. So now I just need to, now I can one-hand the rest of the card. So let's check vCore. vCore is 3 ohms, so that's perfectly fine. Memory controller. There tends to be like a layer of, I think, flux residue built up on most PCBs, so this is 30 ohms. So that red 7950 has really low resistances everywhere. It's kind of suspicious. Oh, right, that's vCore again. Idiot. Memory power, okay, so we have no obvious short circuits on the output. Now, the thing is, I've already had one card with this PCB in the past where there was actually a short circuit, like, several layers deep right in this area. So when I fed current into the card, it just started smoking from, like, inside the PCB in this area. So this may very well be a parts card because there's no obvious short circuit on the output of any VRM. Now we need to check against, 12-volt power, which I don't have high hopes again. I need to get sharper probes. That's fine. That right there is fine. Or more like I need to sharpen these probes. Because the thing is, they were sharp when I got them new, but they're obviously not sharp anymore. So that's fine as well. Yeah, everything looks fine. Okay, so let's flip this over. And check the 12 volts, which actually... Yeah, we can actually... Well, let's go through the inductors. That's more reliable. So there's one of our input filtering inductors. We're just going to go against any ground on the card. That's not shorted. Like, the thing is, if there's a short from 12 volts to vCore, you're going to see vCore resistance going from 12 volts to ground. So there's no short circuits on this. So possible causes of failure is, like, one of the minor power rails not turning on, or maybe even one of the major power rails not turning on, but I can't think of a good reason for any of these not to turn on. There's no short circuits anywhere. But I have had other cards where, like, your display drive rail wouldn't work. And that's the great thing about now having a stack of 7970s. A lot of them should use exactly the same circuitry for the display drive. So if I have a card where the PCB is trashed, but the display drive circuitry works, we can steal the display drive circuitry for this card potentially, if that's the issue. But at this point, I need to turn this thing on in order to see if there's any, like, to figure out what's wrong with it. There's also a chance that there's nothing actually wrong with the PCB, and it's just like the core doesn't work anymore. In which case, I'm going to try reflow it with the toaster. If that doesn't fix it, then spare parts. So that's what's going on with that one. Let's move on to another card. Let's try a different card again. So this right here, I believe is, well, actually, let's just read the label. This is a 280X, so that is basically a 7970 again. And this one, I believe, has... Does this one? Oh, no, this is not the one. So there's one of these has an actual crater in the PCB that you can see from the back of the card. But let's take it apart because I want to see what it looks like. It's got push pins for the VRM heatsink, so... That's, I don't like push pins. Push pins are awful. Oh man, that is, what, the EU. Okay, that's disgusting. These aren't actually that dirty compared to some of the cards I've seen in the past. This isn't too bad. At least they don't smell like cigarettes. That's the worst always, when you get a card that smells like cigarettes. Man, did they, like... This is like concrete for the thermal paste. Did they? Oh, no way. Okay, no, it does move. It does move a little bit. Like, I'm wondering, because I've heard of people using, like, freaking thermal adhesive instead of thermal paste, which is just like, don't do that. That is really stupid. But this certainly feels, like, I feel like I'm going to rip off the BGA if I pull on this. Oh, wait, this has memory thermal pads. Okay, wait. Okay, nope, no thermal concrete, just extremely sticky thermal pads. So, yeah, that's fine. I was really worried if this had thermal adhesive on the core, that was like, okay, well, the core's coming off, and it's spare parts in that case. So non-reference PCB, which is a bit surprising. So that's kind of exciting, because obviously I also have an interest in seeing all the different flavors of Tahiti PCBs that there are. This looks suspiciously empty. Though I'm not sure, like, I'll have to compare against photos of, like, a good card on the internet. I don't have schematics for any of this, so... Yeah. Like, at best, I'm going off of, like, documentation for the various voltage controllers. Speaking of voltage controllers, this is not a chill controller. This is a on-semiconductor... NCP 4206. Interesting. So this might actually be relatively easy to e-power, because the chill controllers, you can build e-powers out of them, but the problem is, if they have power savings enabled, you're going to be you're not going to have all the phases when you turn them into an e-power, and, like, that's actually really annoying, because you don't get the full current handling capacity if you don't have the entire VRM enabled, so, yeah. Now for the push pins, I mean, we don't actually need to take care of the push pins, but I want to see what's under this heatsink. So we are going to take care of the push pins. Also, I should move the mouse off of the stop recording button, so if I accidentally hit it, I don't stop the video. There we go. Man, there. Okay, nice sticky thermal pad. Power stages of some form. What are these? FDMF, of course, Fairchild Semiconductor 6823. That's actually a nice power stage, if I'm not mistaken. That's the 23C, though. That might be the low power variant. Which low power variant, I think for those is like 50 amps instead of 60. Or it might be a 40 amp part. Anyway, so, yeah, so we've got power stages here. Let's do the usual checks again. Is there any fuses on this? Because later Sapphire cards often have fuses, but yeah, I'm not seeing any fuses. There's a shunt resistor over there for some reason. So, let's get to it. Starting off with V-Core. That's yeah, that's fine. You know, anywhere between, like, as long as it's not like 0 ohms or approaching 0 ohms, 30 ohms for the memory controller, that's fine. Which of these, this is memory power over here. We know this is memory power because it doesn't use a power stage. So let's check that. 72 ohms, so all of the main power rails seem to be healthy. That's good. So now, I don't want to be measuring 12 volts to ground. That's fine. Also fine. 12 volts to ground, also fine. Okay, so now we're going to go to the PCIe slot. Fine. And to ground, also fine. So this is another one. I guess this one, yeah, that's fine. Like, I was really hoping for something with, like... So far we have, like, one card where it's, like, you don't actually have to turn it on to know what's wrong with it, which is kind of annoying. I was really hoping for more of these to have, like, really obvious VRM short circuits, but... Yeah, this doesn't. Okay, let's check memory power. A bit weird for a measurement. Try it the other way around. Thing is, there's no, like, low resistance to ground, so... Yeah, no, that's... So there's no short circuits on this. So I really wonder why it doesn't turn on. I guess yeah, so this one is another one that I actually have to turn on, but at least we know that it's not going to catch fire as soon as I try to turn it on, because that's the thing, is like sometimes you get cards, you turn them on, and then they just immediately start smoking, or they just, you know, trip the short circuit protection on your power supply, neither of which is a good thing, because every time you know, if there's a short on the PCB, every time you dump power into it, you're making it worse. Oh man, this thing has a backplate. Okay, let's get this off. I'm starting to realize that me thinking that I can do six cards or 7 cards in a sub-hour-long video was maybe not the best decision. Really overestimated my probing skills. Or more like probing speed. Anyway, let's get that out. And... Okay, so this is a 3... What? What? Man, I'm really glad I picked this up. 2, 4, 6, 8, 10, 12. What's this gunk around these? Did somebody steal the memory chips off of this? Yeah, this is a 256-bit memory controller. Wait, no, so it does have the appropriate number of memory chips. That's not a Tonga, though, is it? No, it is. Like, the cores are different. Wait, what? I'm so confused. 380, yeah. This is a Tonga. The VRM on this is kind of anemic. I hope that's... Oh, no, freaking backplate. Like, the nice thing about the backplate is, you know, it obviously adds rigidity to the card and structural integrity, so some forms of damage might be mitigated by the presence of the backplate, but makes disassembly a bit longer. Man, that is one weird PCB. Also, what is that gunk? Like, is that factory, or is that somebody trying to do something to the card? Like, this whole thing looks kind of... No, I guess it must be... like, they also have the same stuff over here. So I guess that is factory. Weird. I guess we'll see also from the other card, like, if they all have that gunk, then... well, I mean, a sample size of 2... If they're both from the same person, the person might have done the same thing to both cards, right? But, like, so far, well, yeah, so far these haven't really been great in terms of, like, looking like they're gonna be easy to fix. Don't see any obvious damage on the back. Backplate's nice enough. Though, I'm not sure. I don't think it fits any other cards anyway, so that's kind of useless to me. If I don't get the card up and running. Nice little VRM heatsink, though. And if I actually wanted to turn this into an e-power, this is super convenient. Like, the way this is laid out. This should be on an NCP 81022 voltage controller, because it's a Tonga card. Yeah, somebody's definitely taken this apart because there's scratch marks on that screw hole. So they've probably done the same kind of thing that I'm doing to the push pins. Come on, get through. And did I ever tell you how much I hate push pins? There we go. That one's through. And that's the VRM heatsink. Ew. That is disgusting. That is one anemic as hell VRM. Freaking, this is power color. Well, yeah, what do you expect? Like, so this direct FET package is specifically meant for like, well, it's not really, like, there's nothing stopping you from using what is normally a high side MOSFET as a low side MOSFET. It's just that if you do that, that's probably not great. So yeah, that is really disappointing to see. Oh man. If the VRM on this hasn't blown up, I'll be surprised. Now, at the same time, Tongas were slightly more efficient. Like, that's the thing, though. Tonga wasn't that much more efficient than a Hawaii or Tahiti there. Anyway, let's start probing. I'm assuming this being an AMD card, I mean, we can kind of see the power planes. Oh, okay, no, there's something going on over here. And actually, this... Is this all V-Core? No, this is a 17. How many MOSFETs do we have? 1, 2, 3, 4, 5, 6, 7, 8? What? One, 2, 3, 4, 5, 6, 7, 8. Wait, these are dual and what? I've never seen these. Okay, well, sorry, I need to read the part number. $6,852. Like, these have to be, like, dual NFETs. But why is there 8 of them? Man, this VRM is weird. Okay, well, I'm glad I picked this up, because that is one weird VRM. Not in a good way, but... yeah, like, the thing is, I'm obviously just interested in seeing all the different power delivery options, but yeah, that right there is just... If that is not a nice VRM as far as I'm concerned. So let's start checking for, well, let's check the core. Now I'm not sure what the resistance of the core on these is supposed to be. Yeah, 3 ohms sounds about right. Memory power, 20 ohms, that's probably correct. Memory controller. Actually, wait a minute, this might be memory power. Because this is like 70 ohms. So that might be the memory controller. Yeah, Tonga is not an architecture I have a ton of experience with, so this is going to be a bit of a mess. That must be the ground. What? Oh, so we have a short circuit. Yay. So any screw hole on a PCB is also a ground. Though if you're doing like an e-power mod, it is not a ground, because these are not meant for power handling. They're just meant to ground like any backplate or anything like that. Yeah, that's not supposed to be shorted out. So, okay, I think I know why this doesn't work. This exploded. So now let's figure out if this has a short circuit. So this is perfect because I have a stack of Elmore Labs amples, which let me... Well, the desk is too much of a mess. There's probably an ample somewhere, but I can't find one right now. But anyway, yeah, this is great, because that means I can pull the inductor, stick an ample on this, and it'll probably start up, which is exactly the kind of defect I wanted to deal with, as in, I don't actually need to fix anything. I can just replace the entire VRM. Now, the issue is, where do I want to check my 12 volts against? Because this is a pretty awkward little VRM to probe. think this is going to be 12 volts, right? Yeah, and then we're going to check that to the output. So did the low side just explode? Well, let's check 12 volts to ground. Yeah, it looks like, okay, so this is really cool. So it looks like just the low side MOSFETs blew up. Like, there seems to just be a short circuit with the low side MOSFETs. So that's going to be, like, that's really good news. I'm still not sure, like, this being all black and dirty. Like, I hope this hasn't gone through an oven, is what I'm trying to get at. Is just like, because if this went through an oven, then, you know, this might be the defect, but somebody might have already killed it. Yeah, that's the thing, is, like, if I'm measuring, because if there was a short circuit, like this right here is very much shorted to ground, right? So if there was also a short circuit from 12 volts to there, then it would also look like it's shorted to ground, but that's obviously not. So let's try the input filtering inductors over here. Not shorted and also not shorted. Cool, 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 cool. So yeah, this looks like an easy fix. We're just going to throw an ample on this, and I mean, pulling a through-hole inductor is kind of a pain, but it doesn't look like we have too much thermal mass in that area, so that shouldn't be too bad. So we're just going to... So that's great. So this, man, I'm actually hyped about this. Like, I'm excited. No worky. So there. So now I don't need to, like, troubleshoot the whole thing again. I should probably make sticky notes mentioning what each of these cards has wrong with it. Man, now I have all these backplate screws. Solid backplate, though. Also, oh man. Also, I'll probably be doing a PCB breakdown of that 3080 PCB eventually, just because it's a, like, I've never seen those MOSFETs. And that makes me excited. Like, the whole point, the funny thing is, a lot of people think the PCB breakdowns are meant to be reviews. That's not the point at all. I just really like looking at power delivery circuitry. I have issues. Anyway, bad audio. WD. What does WD mean? Did they spray this down in WD-40 or something? Or is that an N? No, that's a W. Bad audio. Well, I guess with this one we can figure out if, you know, we're supposed to have a short circuit on that power rail. But this one sounds like this. This looks like this actually works, and it just causes some kind of issues. Maybe this one has, like, super extreme coil whine, which wouldn't surprise me, because these both, like, this... Like, we can see already on this PCB, these are SMD inductors. SMD inductors, though you can generally get them in much higher current capacities and just superior build quality, like, superior in electrical ways to your through-hole inductors, they unfortunately have a nasty tendency to be incredibly whiny because, well, they're basically a bunch of metal glued together, and they tend to be a bit loose, and they rattle really bad. Okay, so it's pulled apart, and now we can find out what resistance this rail is supposed to have when it's not shorted, because I'm assuming the bad audio on the backplate means that this thing actually turns on and then it just causes audio issues, which, that's, like, I don't care. Oh, this one went through an oven. This one definitely went through an oven, or somebody ran it over with a heat gun. Man, this... So I'm going to assume that all the other ones were run over with a heat gun. Man, freaking... Because, like, the substrate is all bubbled up here. Now, that doesn't necessarily mean that this is dead, but that is not a good sign. That is really not a good sign. It's just like, don't just freaking heat gun things if you don't know how to do basic measurements. I mean, I guess that's also why I got these cards so freaking cheap. Oh, no, I'm measuring from the wrong place. Yeah, so as we can... Oh, wait, I'm zoomed way in. Sorry about that, guys. Forgot that you guys need to see the multimeter. It's not just for me. Anyway. So that's what a healthy version of this card... Yeah, it's supposed to have like 300 freaking ohms. Not 0. You know, so yeah, this side of the capacitor is actually ground, and this side of the capacitor is power. Right, backplate's still on. So this one's obviously being heat gunned, so I'm going to assume that they... Yeah, so 4 ohms... Why is the core resistance so much higher? I might have been too hasty with the other one. We're going to have to check it over again. But that's fine. So this right here... Yeah, that's fine. Yeah, okay. Cool. So I'm going to check the other one again, because that core resistance being so much lower is kind of like, wait, what? How is that possible? Also, I guess now we know that, like, man, but freaking, like, this is why I'm not an advocate of the oven trick, because there's a lot of GPUs that don't have an oven problem, okay? Like, they just don't. And so if you don't have an oven problem, well, at the same time, none of these is shorted to ground, so maybe this one just has a naturally low core resistance, which does happen. Like, there's a general range of acceptable core resistances. I just wasn't expecting an ohm between two cards using the exact same PCB, but yeah, no, this is fine. There's no short circuit. Okay, it's just a low resistance core compared to the other one. And that leaves us with the last two cards. So we have another Dual X. This one has an exploded PCB, so that one's going to probably need an E-power. And this one, I don't know what's wrong with this one. Let's check. Let's take a look. So this one has the warranty sticker, so I'm going to assume that this hasn't been run through an oven. Or the person was very, very careful about replacing the warranty sticker. Like, I actually like the warranty stickers now. Tells you if somebody's been, like, it's a really good giveaway if somebody's been really tampering with the card or not. Alright, so, let's see. Okay, this one comes apart nice and easy. So, fun fact. Okay, that's actually... So, on some of these Twin Frozer cards, this, like, raised section for the core is actually just a sticker, and you can just, like, jam a box cutter under it and scrape it off, which is... Yeah... Probably not the best for heat dissipation, is it? The thing is, I might be able to, like, I'm kind of hoping to reuse the heatsink from one of these for a 290X that I have that doesn't have a heatsink. And I have a bunch of other cards where it's like, yeah, I'd rather have, like, the power color, no, not the power color cards, but that red PCB, oh, this one has a broken fan cable. Okay, well, in that case, I don't have to worry about it. So, yeah, and as you can see, I've stopped taking good care of tracking all the screws. So we're going to stick one probe in ground and go to the core, and the core is good. And our memory controller is good, and our memory juice is also good. So memory juice is fine, memory controller is fine, everything looks fine so far. So maybe this is another one of those cards that just doesn't work for no reason. Like, it wouldn't surprise me, because it's not like the VRM on these is underpowered, and they do have a rather nice baseplate and heatsink, so it would kind of surprise me if the VRM had a tendency to just up and die. Because this technically has more VRM on it than your average 290X reference card. So, you know, and it says have a 970, which really don't pull that much power, so... Wait, what am I measuring? I'm an idiot. Supposed to be measuring this against ground. But that's fine. That's fine. And that's fine. Okay, so this is another one of those that I have to actually turn on before we know what's wrong with it. This one really doesn't look like anyone's done anything too nasty to it, so hopefully it just has like some minor... Like, if one of the minor rails doesn't work, that would be ideal. Also, these should be a relatively... Like, these use a really reference PCB, so hopefully these are relatively early production. Oh no, this is a boost edition. Okay, well... A lot of the boost edition 7970s suck in terms of core overclocking capabilities, so I was kind of hoping to have an earlier production date. It's kind of funny how that works. Like with Ryzen CPUs, it's like the late production chips are really, really good. And actually for Haswell E CPUs as well, there's like some really late production Haswell E chips that are really, really great. And then with like 7970s, it's the exact opposite, where the good 7970s are like the really, really early ones, and then all the later, and all of the ones that come after that, it gets like a lot of them are worse. So like they don't scale with voltage, and oh yeah, freaking Sapphire thermal pads. Man, I hate doing that to cards. Okay, at least the fan connector comes off easy. This heatsink should probably fit a lot of different GPUs. Also, I think this little plate thing might again be a sticker. That's one thing I'll check. And it's also that is also one of the nicer heatsinks out of all of these cards, because, or is it? Oh, none of these really have that bad heatsinks. I have a bunch of like 7950s that have like 3 heat pipe heatsinks, which really don't make me happy. You know, it's like 3 heat pipes is not enough heat pipes. But all of these, I think the lowest heat pipe count on any of these is 4. So one of these is probably a pretty decent option for my 290X. And then there's like the twin Frozer ones, which have 5. Actually, no, this is 3. Okay, no, I lied. These are 3 heat pipes. Yeah, so I have a bunch of cards with like this variant of this heatsink. But yeah. Anyway, let's get back to probing. So first up, core. Is the core healthy? The core is kind of low, but that should be fine. Is the memory controller? Memory controller is fine. Is the memory juice? Memory juice is fine. Okay, so now let's go check for short circuits. Is this shorted to memory? Actually, we can just check against ground. Okay, that's fine. That's actually definitely the faster way, because if you have a short circuit to any of the low resistance rails, then you'll just have a short circuit to ground from 12 volts. Ah. Because I believe this is the one with, yeah, this one has a crater in the PCB right here. So let's pull off the heatsink and see just how bad the damage is, but it's probably pretty awful. Hop. Oh boy. Ooh, yeah. I burnt the thermal pad. Oh boy, that is a crater. Yeah, okay, so what I'm thinking of doing with this is, so my main concern right now is like, will this disable, because here's the thing, with any luck, the core is healthy, and so basically we just need to do something about the fact that there's a giant short circuit in the VRM. And because there's a crater through several PCB layers, like, basically the way you would be fixing something like this is you'd have to, like, drill a hole through the PCB potentially, and I don't really have the equipment for that. I also just want I don't want the VRM to be downsized, because this is a 7970. They can pull, like, if this has a decent core, then running it at at full clocks is going to pull a significant amount of power. So what I want to know is if we've shorted out memory juice. Okay, so it looks like the memory VRM is not connected to that. Yeah, the memory VRM doesn't seem to be connected to the crater. So what I'm thinking is if I e-power this, I should have the memory VRM up and running. So I don't have to worry about this. I just have to worry about the vCore portion of the operation. Assuming that this doesn't run off of that controller, but we can check that by looking on the back. Nope, we have that's not a driver, is it? Nah, that's not a driver, that's a controller. Yeah, so we have a controller over here. We should also have a controller somewhere for the memory power, which is probably this. And indeed it is. So that is a 5230 from On Semiconductor. Man, I don't want to stick my head under the camera. Yeah, that's a 5230. So we have a 5230 over here, which is going to be taking care of memory power. So we just need to, like, when I e-power this, we just need to take care of making sure that turns on. Then on the other side, we need to make sure that this turns on. And then the vCore VRM probably going to pull the controller, pull all the inductors, pull this shorted out input filter, jump the power connectors so that the card doesn't know that because the card will a lot of cards will have a safety feature where they'll complain if the power connectors aren't plugged in. And I think it's this one that's shorted, right? Yeah, it's that one. And this one's fine. So we can keep this one plugged in. And just need to get rid of this one. So pull all the inductors, which that's going to be a pain. Like, through-hole inductors are really annoying to pull out because the power plane that they're soldered into has a lot of mass, and so it just sucks up so much heat before they start getting out. Also, the material that they're actually made of, like the sintered metal cores that they're made of, it softens up as you heat it up. So at like, I think around 150 degrees, if you grab at it too hard, they just kind of start disintegrating. And if you go much above, like once you get to like liquid solder temperatures, like the core materials just start turning into dust if you squeeze them too hard. So that's really messy and annoying to pull them out because, yeah. Because also like the solder actually just the surface tension of the solder will actually hold the inductor in place a lot of the time. So yeah, that's gonna suck to pull, but it looks like this should be relatively okay. We have a massive power plane on the back, but I'm not seeing a lot of easily accessible ground. Whereas on the front, it looks like we have a decent, like there's ground, like you have ground power, because of the rows of capacitors that we have. But yeah, so this'll be interesting. So this will probably get an E-power. It doesn't seem to have any other damage. So, yeah, that's it for this video. Unfortunately, my soldering area for right now is inaccessible. There's just too many boxes in front of it. Because also my flat's getting like redecorated now that the walls have been like that the insulation's been done in my flat. So yeah, anyway, that's it for the video. So hopefully, you know, this helps you with your troubleshooting attempts of dead GPUs somewhat. Obviously I didn't show you anything about how to repair them, but that's just like I can't get to. Like, I literally don't have the space to do any of that right now. Whereas I do have the space to just stab cards with a multimeter to figure out what's wrong with them. So, yeah. Though, actually, I might be able to do the ample. Like, the thing is, the ample is not a super invasive... well, actually, no, that's a through-hole inductor, so I'll need the big... yeah, okay, so no. I'm not going to be able to do that either. Like, the thing is, I have a really big soldering iron for E-powers, and it's so big and so hot that I need kind of a lot of space to work with it, because... yeah, it just kind of like if it touches anything, it just kind of destroys it very quickly. Like if it touches anything it's not supposed to be touching, it tends to destroy stuff. So yeah, anyway, there, that's it for the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store, which, same purpose as the Patreon, except you can buy shirts, stickers, posters. You know, you actually get something in return. It's the usual YouTuber merch stuff. So, yeah, if you'd check out the links in the descriptions to both Teespring and Patreon, that would be very much appreciated because it allows me to do things like buy piles of dead AMD GPUs off of eBay to entertain myself with, hopefully entertain you as well. And yeah, that's it. So thanks for watching and goodbye.